my name is Marianne Jackson. I'm from Intel Corporation. We're here at the Intel booth at Supercomputing 2012 here in Salt Lake City, Utah. This is the Architecture for Discovery booth. We are here to discuss the Intel Xeon Phi Coprocessor. We introduced the first one of its line yesterday, November 12th, the Intel Xeon Phi Coprocessor 5110P. The 5110P is what I have here. It's a 225-watt PCIe board with 60 cores. It is the first product in the Intel Mic architecture family.
Hi, I'm Jim Jeffers. I'm, as Marianne said, a software product application engineer for the Xeon Phi product line. I'm actually an author of an upcoming book with my friend James Reinders on the software programming models and usage of the Xeon Phi processor to do high-performance parallel programming. The really unique thing, or actually not that unique about the product is you really approach the product exactly like you would the Xeon from a software developer standpoint. It has its own Linux operating system. It stands as its own compute node in the environment, and then the standard tools, C, C++, Fortran, standard programming models like MPI, OpenMP are all supported on the product.
So we're here at Supercomputing 2012 primarily because high-performance computing and the technical computing segment is the main targets for the first introduction of this particular product line. We are looking at pretty much any segments or any products that can take advantage of highly parallel applications or code. And that's really the programming model that Jim talked about. With Supercomputing 2012, we also have the introduction of the Top 500. Here at Supercomputing, we actually introduced the Xeon Phi, I believe 6 times on the top 500. Seven times on the top 500 list. Actually introduced at number 7 with the Stampede supercomputer, which is actually in our booth as well.
Okay, hi folks. I'm Brian Dietrich. I'm the Intel Business Development Manager, and I manage our relationship with the University of Texas and the Texas Advanced Computing Center. TAC is one of the high-performance compute centers that provide a whole wide range of resources to the open science community to work on a broad range of open science research projects. Stampede is the newest resource that TAC is going to be making available to the broad open science community on January 7th of 2013. And the resource will debut on the November 2012 Top 500 list at number 7.
So this is a live remote streaming demo. It's interactive rendering on the Intel Xeon Phi coprocessors on Stampede. So this is something fairly nice. This is interactive ray tracing. It's standard primary rays with shadows. We also have a volume visualization, which we think is useful for this problem because it helps you visualize something fairly large in a fairly coherent way and do analysis on it that might allow you to calculate surface area or volume or void space, other things that computational chemists might be interested in. Some computations right off the bat will not be perfectly tuned for the Xeon Phi necessarily, even though they probably stand a better chance of getting tuned on the Xeon Phi than other architectures. For architectures that aren't, for computational codes that aren't necessarily tuned for the Phi, we can actually use the Phi for something else, namely fast rendering and analysis.
So we think when Stampede is fully operational, we'll be over 6,400 nodes of Xeon E5 processors coupled with the new Xeon Phi coprocessors. As the production system becomes available, we believe there will be hundreds of researchers representing thousands of open science research projects that will be utilizing the resource made available through the Texas Advanced Computing Center. Essentially, this resource is funded by the National Science Foundation, and it's available to all members of that community. That community is represented by an organization called Exceed, which again represents hundreds of researchers across universities all over the United States.
Hi, my name is Mike Lee. I am a product marketing engineer in the Developer Products Division, which is part of the Software Services Group of Intel. Last week we introduced the Intel Cluster Studio XE 2013. and it supports both the Xeon and the Xeon Phi coprocessor. Our tools completely support all of our processors and also the Xeon Phi as well. So there's only one set of tools that you need to purchase to gain access to all of our processors. So the great thing about our developers' tools is that you do not have to learn another language to actually program the Xeon Phi. It's built on standards, so with that, the applications that you've built and developed today can scale forward into our Xeon Phi coprocessor. Of course, there's always work to do optimization on it, but at the end of the day, you will not have to recode your entire program. The requisites to get your application ready for Xeon Phi would be to make sure that it is as well as parallelized as well as it can be, as well as threaded and vectorized. Then you're getting the best performance out of your Xeon, and then when you move to Xeon Phi, you will also be getting the best performance there as well. You can find out more about programming Xeon Phi at software.intel.com/mic-developer. There you'll find a broad range of information about how to parallelize and vectorize your code to maximize your performance on both Xeon and Xeon Phi. Thank you for joining us here at the Intel booth in Salt Lake City at SC12. We look forward to seeing you next year at SC13 in Denver, Colorado. Thank you.